why the computer is not listening to the projector?
It was not, the button start class was not pushed here.
Listen to me.
Whoa.
I don't know if I like or not like.
These are stupid.
I thought it like come closer.
Oh no, it's not.
I got one. I feel off now. You and Landon are supposed to sit in the front.
It's too far.
Is that right?
Huh?
Is that right?
Yeah.
Because you understand what's in here.
What if I'm tired of them?
Maybe I can sit in front, and they'll know what's going on.
Right.
Right?
May I sit next to you, I guess?
Yeah.
So when you were approaching, showing this, I thought it is like, give me answer key.
Just hand it to me. I need it now.
I do really want to make sure I get you before this. I like the fact that the chairs are not going to try to, squeeze everything out of me now.
What happened to the desk? No one connected to the chair. What's it? No one connected to the chair. You can really move. It's crazy. Still have a little bit of a net square well for your potential. You know, it might be possible for you to talk about these things. You just have to kind of like hit the chair a little bit and kind of limbo, stretch. Which would reduce the number of microseconds.
Excellent, thank you.
Makes sense, yeah. So it's an unlikely method. There we go.
Well, thanks for coming. I don't know, is it exact time to start or not, but we better start because the program is very intense. So probably you all are very excited and happy with your completed to some degree homeworks. Right? So we have a three-fold program today. So first, we will deal with your homeworks. Second, we set up an option of extra credit so that no one worries too much about grades. And third, we will do actual new material, which will be probably smaller portion than usual. So let me do the following. So I have a suggestion that I hope you will enjoy and I will enjoy for sure. So you will learn more about the homeworks and make sure that you did it right, repeating it. And I will get rid of grading work. You got an idea. So in case some of you are sensitive for others seeing your identity, I have prepared stickers. So you can put a sticker on your name in the work and write your name nearby here.
Sure. Never get so harsh.
And
Oh, so
I mean, if you didn't do that.
put a symbol that you like. Like draw a lion or a rabbit, whatever you, or a star. And put it here.
and bottom
So,
right towards
yes, and now here make the same symbol and write your.
But would it be also true to say A is 10? Because you can always just
Otherwise, I will not record.
Yeah.
Keep it with you.
Right.
With you.
Yeah, as long as.
So this is more specific knowledge.
Okay. So what is your name? So you close it. Make say symbol. Encrypt yourself with something that is unique.
Oh, yeah.
Good. Right here and write your name.
Because we're getting the same problem he has with his examples.
Yep. I don't know, maybe if you all are very...
I mean, I don't care, honestly.
It's well, it's easier to make systematic,
Yeah.
even if you don't care, so... Do the same and write your name.
That's in PDE you pulled up there.
Just
A little C. You just need the first name, I guess.
it's fine, it's fine.
We use that a lot in PDE. Did you have to do
I don't know. I wasn't
Well,
analysis.
probably you don't care about
Turned out
disclosing.
that Dawn was doing like
Oh.
individual functional analysis.
I accepted my fate.
Ended up doing that.
That's part of the staple.
So put a sticker on your name.
Right. See,
Better.
took me forever to like.
Yeah,
I mean, like I'm still shitty at it, but you know.
I don't even do it that fancy. I just like make a
And make some
epsilon.
symbols.
Well, I do an
by
epsilon
yourself.
and then just squiggle on top.
Yeah. That's really fun when
Yep, yep.
like when Friedrich Lippmann does it, he just like literally just does it. Like just squiggles downwards.
Mine's just less artistic.
Right. Yeah, it's weird to draw.
That should be that. It's only one solution.
So you ended up getting
Yeah. Nice. I'm so good.
so
Too good.
we done.
Probably.
Because would you?
Yeah, it didn't really explain through the
Letter, symbol, yeah.
Oh yeah, I showed an operator and wrote a function and because I get equation. Well, this is this. Normalization. Cool. Oh, I see.
Do some,
Yeah, but we did that one thing in class.
But I like 3.
make at least 2 of them because it is not unique.
No, someone else may have to figure it out.
So you want to take this one off? And I just
Maybe.
rolled it. Got something else there.
Mine's a little bit nappy. So like, if someone else is starting this, they're not probably have a fucking idea what it means. They're not gonna understand the mosaic spaces.
Design a symbol.
Because it's technically what we're working on. That's all too good.
Here,
Right, that's what I'm saying, like, you haven't done any like, I mean, shit, even if you have done upper level math, I mean, you'd at least understand the notation.
need.
Oh, yeah.
Yeah.
That's the only upper level one from everything.
It doesn't need to be correct, it needs to be.
Oh, it's unique because it's incorrect.
What are some other things other than that?
Hard, like,
Real-
script
so-
real numbers. Yeah, because
So what is?
Just one more, right?
that's what this is right here. It's the set of functions from like whatever space, right? So in this case, from complex to complex.
So, yeah, no.
Such that the integral squared is bounded.
So, yeah.
Like it's not.
So that's x.
And then you can find a norm on that.
Trick
vector
all the
space,
sort of like carbonate.
right? And like these functions are vectors, right? Which
Well,
is
the titrate
exactly
back,
how
so
we're
we can
doing
like-
and stuff. Yeah, I really wish I would have taken functional analysis before I did quantum. Just like I took quantum, didn't understand what the fuck I was doing for like the entire time. And then did functional analysis, just like, oh, that's why we can do that. Like, oh, that's why we treat it like this. Like, oh my god, oh, that notation. Wow, that's where that comes from. Like the, you know, the Brockhead notation, that's just like inner product notation.
Yesterday.
So, which, I mean, when you find it, like,
I realized that.
Make the same symbol and certain some product.
Oh, well, I mean, that's just, you find it by doing it. It's like the dot product, right? Because the dot product is just a specific.
Okay, now your identities are secured in case you are sensitive. And what we are going to do, I'm going to distribute the answer keys, and you are going to move your work to your next neighbor, to the, let's say, left. And if you don't have neighbor from the left, just make it circle. And then we will go together through grading effort.
You got a digital copy?
Yeah.
Which one are you?
So it's cool if I just like write on it. Right?
Wait, that's
Find that.
Fancy. This is like a, this isn't
Where's this
actually
one?
like right on
That's
it.
not. So
No.
this is
Okay.
yeah.
Oh,
It's
it's like
circular.
the bottom. That's just that.
Circle.
It's like a menu
I
button.
mean, it's
Oh,
not.
It's the bottom button on the.
Yeah,
I'll say.
Oh, there we go.
I mean, just kidding. I didn't just hand that to you.
You don't even know. Okay.
Is it this little guy over here?
No, that's the one it's on the pen.
Oh, I see.
Eraser button right there.
Okay. Yeah. Fancy.
No, it is an answer key.
You crazy? You want more homework there?
That's rough. Oh, Jesus.
Yeah,
What did I say?
Okay, so the total number of points of 100. Do not hesitate to give maximum points. It's the goal of the course is not to put anyone down. Just find benefit of the doubt to give the maximum. I will review it anyway. Do not worry. So the first problem, which was more mathematical than related to physical and quantum chemistry, you were converting a step function from x space to set of Fourier coefficients. So you've found in the Wikipedia that Fourier transform is something that is a procedure that allows to encode continuous function into a set of discrete numbers, and you can save your time and scroll. If the person whom you're grading has the answer like this, you can just assign full credit and go forward. If it is not, then you can try to withdraw points for being far from it. So let me quickly go through the solution. You are showing something to me? So you should see in the solution the function, integrated and normalization factor, and there should be separate effort for coefficients with different index. So one of the things that good half of you, even if the answer is not obtained, should be seen is that in this list, the A coefficients are zeros. So coefficients in front of cosine functions are zeros. And if the work you're grading does have this feature, you can give like more than 50%. 60 is for sure, even if the rest is wrong. And then if the coefficients in front of the sine functions, the b functions are having half of them are zeros and half of them are non-zeros, you can give another generous portion of credits, like 60 for this, plus 20 if the pattern of zero and non-zero is recovered. Okay? So the problem number 2 was basically repetition from the lecture material, right? So let's give 20 points to this problem and assign the 5 points if the Hamiltonian is reconstructed well, 5 points is if the plane wave function is used as the reasonable trial function, another 5 if the person who was doing was constructing eigenvalue problem in the right way, and then another 5 points if the energy as function of momentum was reconstructed in a reasonable way. A little. Please give me a sign if you are not ready with grading number 2. If you have doubts, just give more points. So then give benefit of the doubt.
Can we go back to the last slide?
Yes. And this slide is exactly what has been distributed. So
Oh, right.
How many points total per question?
Yeah.
for
First one's 40.
40, 20, 40, total 100.
So like 0, 1 or like 1, 1? 1,
1,
1? 1, 1?
1, 1.
Okay.
Zero is
Is
not
that
not
40?
Not a problem.
yeah. So the first problem was worth
What about the
the,
zero problem?
Yeah.
it's not on there.
0 is nothing?
The total points is still 100.
Like the whole assignment?
Yeah.
Okay.
Again,
Okay.
do not hesitate to give a little more points than the person deserves. Give points for a good attempt. Okay, number 3. Here, the assignment was to convert Gaussian wave function from Cartesian space to momentum space to find expansion coefficients.
No.
And even if you have formulation of problem repeated, written, reconstructed at the first page, you can give some points for the person recognizing the task. Then all of you should be trying to identify the Gaussian integral, to identify new variable. If you see this effort, see the effort to identify Gaussian integral, even the answer is not quite right, you can give 50%, which will be 20 points. We are not in math class and we cannot punish people for being not careful enough about equations. Let me quickly scroll to the answer. If you see the correct answer, just give full credit and do not bother with reading the rest. So if you don't, just go through recognizing effort and the variable in the power of exponential. So the set of variables, the position and momentum, should be converted in a form to identify full square by multiplying and subtracting. You will see that it is a product of two variables, and then adding, multiplying and dividing, and then adding and subtracting. If you see this effort, give another 5% irrelevant of the answer. Okay, and if you see this notation where there is some factors in front and then the person has identified the Gaussian integral that you know should be square root of pi, give another 5 points. Okay? So I'm counting until 30 and then starting to collect.
How do you want to collect this?
He will convert it into PDF and send me as an email.
Okay.
For the last time. Next time, everyone will bring it printed.
Oops. Yep.
Okay? 10. I'm counting for 20 seconds more. Just complete. 20. 30. Okay. So the graded work is for me. Answer key is yours forever.
Because I didn't have it all.
I just subtracted.
That's how you I don't even How many is 21? Are you for 4 guys?
No, like some.
Yeah, 40.
Complete well on trouble.
Just subtract something.
Because they are.
And then like by doing a bunch of weird stuff, you end up getting that. And then go with that as a square root of five.
Oh,
But then you still-
I am impressed how well are you doing. The grades are really good. Congratulations. What
Like
else?
3 in the morning.
Round up and
Okay.
you don't have
I'll let you grade it. I don't remember how much. You can do that.
Yep.
I was quickly going
No,
through.
I was just.
Okay, congratulations with successful completion of the homework. And in case you are still worrying about the grades and you want to accumulate more and more points, we will have another initiative as a part of the class. So, although you performed well in this assignment, you see that it is a very substantial challenge. Even if we do very primitive effort in quantum theory, it is with all my good wishes, we cannot simplify it to solve these problems in 2 minutes. They're hard. But we want to get concepts, not the cheap piece of this little effort, although it is never hurts to get this training, but the time for the course is not long enough. So we do have a bypass. Some of the problems will be simplified by solving them numerically with so-called MATLAB 2 code. And you are invited to visit optional MATLAB lab tonight at 5 at QBB
132.
132, thank you. And in 1 week and a half from now, you are invited again by Freeview to make presentations in class, teaching 1 week and a half. Not coming Friday, but next Friday. You're invited to give little presentations on how to operate the software. This is not literally physical chemistry or quantum theory, but with this auxiliary help, we will move forward like a rocket. And you will assist each of you will hopefully assist the success of the whole class. Yes?
So with those presentations, are you doing it like last time? You give us each a little section they
Yes.
go over? Okay.
Yes. And then each person becomes expert in one section, and we all become certified experts in the whole piece of knowledge. So I have printed these sections. I will distribute one for everyone, and then another one for me that you will feel. But it is for your memory, and you can look through and decide what are your choices. You are also invited to make more than one choice. Like first preference, second preference, so that everyone gets happy about making presentations. And this, let me put symbol here. So this one with smiling face, please pass it through and complete by the end of the class with putting your preferences. So I want just one piece of paper with your names near the subjects. Okay, so half of the time is completed, and now we go to the lecture material. So you can lean back, relax, fall asleep. I will give you a signal when there will be something truly important to follow, to record. And if you're curious, you can stay awake all the time. So, who we are and what are we doing? We are in the physical chemistry class. And our goal is to understand mechanisms, at least, and at most to get an ability to predict outcome of several physical chemistry experiments, such as NMR, UV visible spectroscopy. And this path is not possible without some background in quantum theory. So most of the time, although our goals are ambitious and practical, most of the time we are doing more or less boring or exhausting learning of quantum theory. So since beginning of the course, we have got several fundamental concepts, and through your presentations, we all became familiar with them. So you are certified experts in postulates of quantum theory, and we have got several analogs of lab protocol, like prescriptions, how to solve quantum problems, and which allow to do what? To predict what? Future. Future of what?
An electron.
Yes, future of electron. So dynamics, evolution of electron forward in time. And how many tools, how many methods of predicting future of electron we have by now? Yeah. So skip first two. What does the third one is based on? Just give some keywords. It is not for record or for the grade. Like the prediction of the future of time evolution of electron is solution of time dependent Schrödinger equation. But would you agree that in order to practice the solution of time dependent, you need to solve which one?
Time independent?
Yes, so eigenvalue problem. And this third way of solving this Schrödinger equation is based on several components. So solutions of time-dependent eigenfunctions and eigenenergies added together with expansion coefficients. Right? And expansion coefficients is literally what you did in your homework problem number 3. So by merging together the eigenfunctions, eigenvalues in the power of exponential to accumulate phase, and expansion coefficients that correspond to the past, to initial condition, you can predict how the electron will evolve in time. Then we decided to look onto oversimplified test problem to check if this method is working. So we looked on the universe that doesn't have molecules, doesn't have ions, and has only one electron. And then we applied this methodology. Which question were we posing while making this scientific problem for us? What did we ask ourselves about behavior of electron if it is initially localized in a specific space?
It would grow or...
Yes, exactly. Whether it will grow or contract, expand or contract. And then we applied all this methodology, did some math tricks, and got that we can assign a variable for the width for this distribution. And what does this width of distribution do with time? Expands. Does it expand like linearly in time?
Quadratic.
Quadratic. Okay, perfect. So No doubts that you are following what is going on in the course. And we were not the first who observed this property, so that width of the distribution grows, and then at the very last 2 minutes of the last lecture, we did very important conclusions that can be projected from this property of electron wishing to expand, to take more space, if there are no attractive ions. From intuitive, from regular common sense, we are happy to, well, more or less happy to look on the distribution in Cartesian, in position space. But at the same time, if we were using plane waves as basis functions, then expansion coefficients in this plane wave basis are sort of replacement of wave function, or wave function in momentum representation. So these fractions of which percent of electron has a given momentum is distribution in momentum space, and it is another way to represent wave function, right? And then we did a, I don't know, either congenial or silly thing. We decided to look on the width of this distribution in momentum space and position space, multiply them, and look what is happening. So in momentum space it doesn't change, and in position space it expands. So the product grows, right? And if we carefully cancel all factors, we see that the answer, the product of this width, distribution width, is proportional to h bar square, to Planck constant square, plus additional term that grows linear, right? So this conclusion that you guys derived for free electron is very fundamental feature that will work for any electron in any environment, in any molecule or any material. So that width of distribution, which can be referred to as uncertainty times uncertainty for position and momentum, cannot be smaller than Planck constant square. It is equal or bigger, and often it just expands. So this is referred to as relation.
Uncertainty.